What's up? In this tutorial, we are going to create a blueprint tool using PCG that we can drag into our world and use a spline inside of that tool to very easily build out a road system. We're also going to create an option to turn on a crossroad segment that's connected to our road so that we can very easily build out larger road constructions. I'm also going to really be trying to explain as we're doing it how to actually what's really going on with the spline spawning in PCG, which is a new update in a more recent version of the engine. So if you're interested in using this type of approach to not just extrude roads but other things with PCG, this is a great tutorial for you. Let's get into it. And the first thing we want to do here is to create a blueprint. If you're not familiar, blueprints are just empty actors that can contain logic. This is a really good basis for us to build a tool that we can reuse that incorporates PCG logic, but isn't necessarily dragging a new PCG graph into our world every time we want to make a new road, or one big graph that's kind of hard to modify and then all these splines everywhere. This is a nice way to create a compact tool we can reuse, and we can always add additional logic to it later, and it will populate across all of our splines. Okay, so let's go ahead and right click here and come to blueprint class, and we will choose actor, and I'll call this BP_roads, and we'll double click on that to open it. Now in this empty blueprint, so we want to create the base actors that we're going to be using, which first of all is a spline, because this is really going to be based around a spline. So we'll come over here and hit the add button and type in spline, and we want just this normal spline. I'm going to drag this spline onto the default scene root, so it's at the it is the root of the asset here, or this blueprint. I don't need a default scene root, I just literally need a spline. Okay, and we'll go ahead and hit add and create a PCG graph too. And this is of course where we will put all of our logic that will be part of this road. And we'll go ahead and come to the spline here. I'm going to actually drag this. I'm going to come over here to somewhere, this empty space. I'm going to drag this in here, and we are going to go ahead and look at this. Something that can be really useful when you're building spline-based tools is a little checkbox here inside of your PCG, or inside of your blueprint rather. If we go ahead and we select our spline, what we want to do is come over here down to the scale visualization width. Switch this on. Now have these kind of useful handles so that we can kind of see our spline a little bit better, and it's a little bit easier to work with it and select things about it. I'm going to go ahead and scale this all the way up to 350. This will be really whenever we drag our spline in here, it's going to be a lot easier to see our spline and make adjustments to it. So I'll come over and click on my viewport here, and I want to give this spline a little bit of distance by default. I'm going to click on the point here, and I'm going to find which point is my first point, which is the point has an input key of 0. So this is my first point. I want to go and click on my second point here and just drag it over a little bit, that when I make my first road, I have a little bit of a segment here. If I go ahead and hit compile, you can see it's made that adjustment. That might be a little bit too far. I'll drag it back, compile, and save. Okay, so every time we drag our asset into our world, this is what we're going to see. So very easy to start working with. Now, what we want to do is come over to our PCG graph, and we need to go ahead and see our PCG graph here when we select this asset, and our blueprint doesn't have any graph connected to it. So we need to go ahead and make one of those. So I'll right click and make a PCG graph, and we'll call it PCG_road build or something like that. And we'll open up our blueprint. I'll come over and drag our new PCG into our graph input in our blueprint. Go ahead and hit compile. And now we have a graph in our blueprint set up. So let's go ahead and open that graph up. Bring us over here. First, we need to go ahead and get our spline information that we have inside of our blueprint here. Obviously, we've made a spline already, so we just need to get that data in and we can start using it. I'll right click and choose Get Spline, and we're going to get spline data here. All right, and that's actually all we need to do. Let's go ahead and hit A and check by expanding our data structure here at the bottom and clicking on it and just checking that we have data coming through. If you're not familiar, A is what we use to inspect what data is coming through each of our nodes. When we've done that, we can come down to the structure of our graph here and click on it, we'll display all of our point data, and you can see we're getting 2 points, which represents these 2 points from our spline. So we're getting our spline data in all right. Now, let's start digging into how we actually use splines in PCG. So getting spline information here, you can notice that we get this type of data. It looks like this cyan color, and this cyan color represents a spline data type, which is not just points, it's points that connect together to make a line. That's basically what a spline is. You can even see here this visual. It's just 2 points and we're drawing a line in between them. Now we could go ahead and grab this and go ahead and spawn a mesh on it with a spawn spline mesh here. So we could go ahead and choose spawn spline mesh. We could go ahead and do this right away. We could expand our spline mesh descriptor up here, which is very similar to the static mesh spawner. We can go ahead and add a static mesh here, and I have a static mesh I've saved here, which is a very simple road mesh. So I'll go ahead and drag this in. And you can see we've now instantly spawned a mesh on the spline. And this mesh is a little hard to see, but it's kind of stretching. It's stretching this mesh along our spline. We don't really have a lot of control over how many times it's repeated, for example. We have actually 0 control over any of this stuff. And so that's why this is not the most ideal way to set up a spline extrusion along, a mesh extrusion along a spline in PCG. Yes, it technically works. We're getting our spline data and plugging it directly into a mesh, and you could do this, and maybe with your mesh it will work fine. But we want a little more control and a way of deciding like how many meshes are spawned along the curve and so on. So the way we achieve this is that we, instead of just straight using our spline data, we first sample the spline. So if we get a spline sampler, this spline sampler is going to actually take our spline and convert it to points. It's going to get points along that spline. And then what we're going to do is, using the more specific settings in our spline sampler, we're going to choose how many points we get along that spline. And then when we have the appropriate number of points, the number of points that we like, we can take that and then convert it back to a spline. Take those points and create a line with them again. So it's kind of like you're taking it into the point world so that you can get the data you need and like control it. And then you're bringing it back over to the spline world and saying, okay, here's your new points. Here's a new spline. So we're kind of destroying the spline and then remaking it with our own parameters that we set up. I hope that makes sense. Next thing here is to just create a spline. So if we go ahead and create a spline from these points, now we're taking the spline sampler, which is getting the point data, which is these blue points. In fact, let's go ahead and look. It's getting 3 points here along the spline. I'm hitting A again to look at the data that's inside this node here, and we're getting 3 points. We started with 2, now it's sampling the spline. We're getting 3 points along the line, and then we're creating a spline from that. And now we can go ahead and we can spawn our meshes again, and it's still working here. So that's great. Next though, we want to look at this spline sampler. The spline sampler is, like I said, where we're going to actually have some control over how many points here. For example, the first thing I'll probably do here is change the mode from subdivision, which is basically going to just give us the number of points based on how many vertices we have in our spline. That's going to be what it uses to determine how many points and therefore how many meshes we're spawning along it, right? And so that means like whether they're far apart or they're close, it's still spawning the same number of meshes, and so they're going to probably be stretched pretty far in between those 2 points. What we need to do here is actually come to the spline sampler and switch it to distance. Distance is going to then take the spline data and create a certain number of points between those spline points based on their distance. So it'll always be the correct kind of ratio of points in between each spline point. And we can see the distance increment is where we decide how many points should be in between. It's a distance increment. So every increment of 100, we should have another point in our spline, right? I think the increment that I'm going to use here is 800. And there we go. So now we have 8 points, and let's see here. Let's test this. So if we go, let me contract this a little bit. we go, hypothetically, if we move this point, we should increase the number of points that we're sampling along the spline, right? Because there should always be in the same number of points, the same number of meshes, because we're now sampling by distance, right? So if we increase the distance, we're going to increase the number of points along that spline. So let's double check that that's working. So I'm going to increase this distance, and now we can see there's a lot more points here. Well, not a lot. There's just a few more points that it could fit along, and I can keep dragging it and dragging it and dragging it. Great. Something else to keep in mind though is that as we're using this distance modifier, I like to turn on fit to curve. What this is going to do is that you'll notice actually if I turn that off and we look here, since it's sampling by distance, it's going to try to get as many of these fit in here as it can. And then if it doesn't have space, it's going to stop spawning. You can see that here. So even though this is the correct number of points, and it's not actually going to spawn a new mesh until it gets the proper distance. And then it can fit a new one here, and so it'll spawn it in. For you, you might not care if there's just a tiny bit of stretching to your points, so long as they all fit within the spline that you're using to actually model your roads, for example. So in that case, if you switch on fit to curve, it's going to go ahead and do some like finagling to kind of stretch them just a little bit, keep your same distance sampling option that you have here, but kind of like make sure that they all fit on the curve. And that is going to always now be exactly fit to this curve here at the end. That's probably what I would recommend going with, unless you're very sensitive to your road mesh, like even stretching just a tiny bit. I think most of the time it's fine, and all you need to do is just, I don't know, make sure that your distance increment is set up so that your correct number of meshes is spawned along the spline as you would like. I just want to mention really quick, for those of you who aren't used to using splines, are basically 2 points, not 2 points, they're just points connected by lines. And those points are connected by lines, and they have a kind of a curving feature that when we turn the points, they sort of slowly blend between them. And the way it decides how to do that is these long, skinny kind of handles, and these are called tangents. And so we can move those tangents to kind of adjust how the curve is kind of entering and exiting each point. So we can see if we make the tangent pretty small or pretty big, you can see that the curve changes. So that's the kind of curvature entering and exiting these points. And then if we want to move the points themselves, we can go ahead and click on them and we can move and rotate them. And if you want to extend a spline and make it longer and start adding segments to it, what we do to do that is hold down Alt as if we were going to duplicate something. So we hold down Alt and we click and drag, and that will go ahead and duplicate and add an additional spline to our spline component here. And we can do that any number of times to create a complicated road system. That we could come back to our curve, click on a point and adjust its tangent if we want. And yes, that's how we would go ahead and model our spline. That's how we set up our basic spline extrusion using PCG. You can go ahead and do the modeling that you need to, and then we can go ahead and drag in another one, go ahead and start expanding it and extruding it as well. Very easy to use, and we can very quickly build out a more complicated road system. Now, we can make it a bit easier for ourselves by adding in something like a crossroads here that will automatically spawn at the end of our road when we're ready to actually divide it into other roads. So let's go ahead and set up some logic that will automatically spawn a new tile that respects the curve of our road. This is key because this is actually pretty difficult to like drag over a crossroads mesh and then have it kind of like adjust and fit the end of this road exactly. What we're going to do is we're going to take this curvature and just make some new points that come off at the end of this curve, and then use that to kind of add on a crossroads or any kind of additional road detail at the end of the road, but respecting this curve that we've been modeling. To do that, we'll need to jump back into our PCG graph. Let's go ahead and comment this, and we'll just we'll type C and call it road. And we'll go ahead and we'll drag off of this spline sampler. We'll actually keep this outside of the road comment. we have our spline, we're getting our spline, we're sampling it, we're getting a bunch of points. And now let's go ahead and find the last point on this spline. How would we do that? How would we find the last point on a road or any sort of spline? The answer to that is by the index. When we look at these points here, we go ahead and hit A, we look at all of our points, we can see, depending on how we set up our spline sampler here, we have a bunch of points. These are 18 points along our spline. That means that this last point here is our last spline point, number 18. Now, the issue here is that this number will often be different. You know, for example, right now it's 18, but if I go ahead and make a new segment to my road and I come back here, it's now 21. This is going to be changing. Our first point is a lot easier to get. It's always going to be index 0, right? It's going to be this number 0. This is always going to be our first point. So if you wanted to set up your crossroads from the first point, that's pretty easy to do. But the way I like to build them is kind of sequentially when I'm building roads. So like the first one, and then I get to a crossroads. I want to spawn a crossroads there, and then I want to add a new spline starting from that new crossroads so I can position it perfectly and then start extruding it out from there. So that's personally how I like to approach it. You, of course, could do it from the first point. I like to use the last point. So there's a little bit more logic involved to get the last point, but I think you'll be able to tell by the end of this tutorial how you could do the first point as well. So let's go ahead, and the node that we want to get here is called attribute select. We'll go ahead and hit attribute select. What attribute select lets us do is it lets us actually select a maximum of something. And that is an attribute. Like we could select the maximum of an attribute of a set of numbers. We could select the maximum number. You can see here by default it's like selecting the minimum, but we could go and switch it to the maximum. And so this lets us select the maximum number in a sequence, which in this case is exactly what we want. So we can come over here to the input source. We need to tell it which number, which attribute here in this list of attributes at the bottom we're looking at. If I switch it to index, we are selecting the last point here. So let's go ahead and hit A to look at it. Great. So we just selected one point. The issue now is that we lost its index number. It's actually just saving it. It's saying, okay, well, I found it. Where should I put this last index number? It doesn't, and I'm not telling it anywhere. So it's just adding it in integer 32, because it's like, I feel like you should still get this data of which index we chose, even though there's 1 point left, because the index of 1 point is 0, but it's saying, well, we found the index was 21. And so we want to store that information somewhere. And you haven't told me where, because there's none here in the output attribute name. So I'm just storing it in integer 32. So let's go ahead and give it something to save it in. And I'll just call it end index. And when I hit enter, now you can see we have a point with the end index set up here at 21. Great. So we now have a point that is at the end of our spline. We could go ahead and take this and spawn a mesh on it. That would be pretty easy, but that would really just sort of stick a mesh here on the end, and it wouldn't necessarily respect this curvature that we have going with our road. And it would probably look pretty good if you have like right angles in your roads and they're very straight. It'd probably be fine. But a lot of the issue when we're dealing with crossroads, specifically in these spline road setups, is that we run into this issue where the edges don't quite line up correctly, and they kind of, we have to do a lot of finagling to kind of get the crossroad edge to line up exactly with this road edge. So that's why I want to keep this in spline world here and just continue the curvature of the spline and use that to spawn an additional crossroads mesh. I hope that makes sense. So we have our spline, we have the endpoint. What I want to do is get the endpoint and the point right before it, because the point right before it is going to tell me the angle of the spline, the direction it's kind of going. It's kind of like if we were to make a prediction of where the spline is going, probably we want the last point on the spline, but we also want the point right before it. So we can kind of extrapolate between the two of them, kind of the angle that curve is taking, right? So I do have my final point here. So let me get that point right before it. And again, this is more difficult because that last, index, the number of points will be different every single spline we do. So we need some way of kind of getting the point and then backtracking and getting the point right before based on the index. bear with me here. It's a little bit counterintuitive, but what we want to do is come and grab these points again, because this is my list, right? This is my list of points that have all of the indexes in them, right? All of these guys. So I'm going to drag off here and choose an attribute filter. This attribute filter is going to set up to look for an index that equals something. So if I come here, attribute filters, filter things out by different operators, greater than, equal to, those sort of things. So if I go and switch equal to, and the target we're looking for is index. So I switch it and I switch it to index. Great. Now we're looking specifically for an index that equals what? So now we need to plug in what our filter is here. So what index are we looking for? We're not looking for this index. This is the last index. But what if we looked at this index -1, right? So if this is index 20, all we need is index 19, right? And then we have the 2 points. So we could take this index, subtract 1 from it, and then look for that index in this larger list of points. Does that make sense? So let's go ahead and we'll talk through this as we're doing it. So we'll take this point and we'll take a subtract. I saved the data into end index here. So actually I need to plug this in here. So I'm looking for that attribute end index. So I'm going to go ahead and type in end index. So that's the number of the last index, right? That we found in this attribute select end index, and make sure I spell it correctly. We're going to subtract 1 from that end index. So we'll go ahead and right click and type in create attribute, which is the way we kind of create a single number that we can use. So we can create an attribute, make it 1 and subtract it. So now let's look at this. So we hit A, looking at this attribute select, we get our point and the end index is 21. And now here we get another point and its index is 20. And if we come back and we change our curve here, we add more points. Now we can see that this attribute here is 26 and 25. So it will adapt to our curve now. Great. So now we have one index, we have the other index. Now I can plug this into the filter and now I can get the previous point on the curve. So now I have my last point on the curve and the point right before it. The way we create a curve out of this is we right click and we create merge, so that we merge these 2 points together. And we'll plug first our first point in here and then our second point. Then we'll come over here and create another spline. And then we'll go ahead and spawn a spline mesh, same deal. And this one, we'll go expand this mesh descriptor, and I'm going to contract this down here. And I have a mesh that I have created and prepared for this, which is this crossroad mesh. So I'll drag that in. All right, let's go ahead and hit save. All right, so we won't actually see anything because they're overlapping each other. But if we go ahead and we disable this other road mesh spawning, we will see that our final crossroads mesh has been spawned directly at the end of our spline here, which is great. So if we enable our other meshes, we can see it's just right on top of this last spline point here. Now, here's where it gets tricky. So we have our points here. We have our 2 last points. What we really need is the next 2 last points. We have these 2 and we want to kind of use where they are in space to extrapolate how we could put one at the end, okay? So we don't actually just need just these points. We need to take them and find kind of their trajectory and create another point over here and then use those 2 points to spawn the meshes. And that way this mesh that's a crossroad won't be spawning directly on top of the road. It will spawn after the road. Now let's go ahead and disconnect these. And what we want to do is come and how would we find the distance between these 2 points at the end here? Well, we would go ahead and we subtract one from the other, right? So we'd find, and that would give us the kind of differential between those 2 points, which we could then use to add back on top to create the next step in this trajectory, right? So we'll go ahead and we'll right click and create a subtract node. And this filter will go, inside filter will go into B, and into A, we will plug the actual first point, or last point rather, last point here. So that's going into A, and into B is going our actual second to last point, right? So let's come over to the input source and put position. So we're subtracting position from position. So we're taking that differential and we're going to go ahead and we're going to take it and add it back onto the position of that final point. So we'll take that final point, we'll make an add node. And so we subtracted the second to last point from the first point, or from the last point. Now we're going to add that difference back onto it to basically push it further. Okay. And so now we're adding the position back over the position, and now we can plug those in. So this is a point. This is a point here that has taken the position of this final point here. It's looked at the point that comes right before it and how far they've traveled and the direction they've traveled, which we got by subtracting them. And then we're taking that difference and we're putting it back over top and creating another point right over here, right? So that it, whatever direction these 2 points were going, we're just continuing that and adding another point at the end. So that will be our second point, and our first point will be our original final point. So we'll use the merge points to connect those two together, and now we can see that we've successfully taken those and kind of added an additional one at the end. If you found this video helpful, shoot me a thumbs up or a comment to let me know, and of course, always subscribe for more tutorials like this. If you're interested in learning Unreal Engine specifically with me, you might be interested in Aziel Art Academy. It is a combination of all my courses in one place, regular coaching and custom tutorials, and a great private community where you can share your Unreal Engine journey, get feedback on your projects. If you're interested in something like that, you can find a link in the description. Final thing here is just to organize this a little bit and create a Boolean here at the beginning for us to turn this on and off, because we don't necessarily want this spawning every time we add a road. We just want it spawning on some roads, and so we need to kind of create a tool for ourselves to switch that on and off. First, let me do a little bit of organization here. So I'm going to come over, double click here to create this pin, which I can use to just reroute things a little bit, create something a little bit more organized. I hope this visually makes sense here. So we're taking the last point in our sequence, we're getting its index, so its number, and then we're subtracting 1 from it to get the second to last point. Then we're subtracting their two distances, their difference between each other, to get how far the point has traveled from point 22 to point 23, or whatever those last 2 points are. And then we're taking that and we're adding that back over top of the original point to get another point that has a little bit further down that trajectory. And then we're merging those to make a spline, and then we're spawning a spline mesh based on that, which will then therefore kind of respect the curve of our spline road that we've created. So let's go ahead and take this and we will comment it and call it Crossroad. We'll move it down here. Now, when we create a switch, like basically turn this on and off, what we're going to do is create what's called a switch node, which is going to be how we basically turn on the crossroad or off the crossroad. And we'll go ahead and we'll disconnect these and we'll plug this into the default input. So this switch is going to just be either 0, so no crossroads, or when it's turned on, the default will take over, and we'll plug that directly in between here. Now, we need to control this somehow with a Boolean. So we can see here that the integer selection here is like, we could have a number of integer options, but there's really just 0 or 1. We can control that with a Boolean, like an on-off switch. So first, let's make that in our blueprint. So if I come over here to our blueprint that we added all this stuff into, I can come down here to my variables and hit the plus button. And by default, it does actually make a Boolean. So I just need to call this something. I'll just call it Crossroad, and we'll turn on the eyeball because we want this to show up in our blueprint on the outside of our blueprint as an option when we drag it into our world. I'll go ahead and hit compile. Now to get that attribute into our PCG graph, we'll right click and we'll type in actor, and we want is the get actor property. So it's going to get a property from ourself, which is an actor in the world. And in this case, we just need to tell it what that property is called. So I call it Crossroad. So if I come over here to my property name and I type in Crossroad, now I can expand this, plug it into the enum value. Oh, rather the integer selection, not the enum value. This is the way we select the whether we're 0 or 1 here. And with that turned on, we want to probably choose if this is on or off by default. So the crossroads I will have off by default. So that's good. So I'll hit compile and save this graph, and we'll come expand out here. Now, let's check if the crossroad is something we can turn on. So go ahead and click on one of my roads here, and I'll come over here, and under default, you can see here I now have a new option to turn on my crossroads. And this will just affect whatever blueprint I have selected. So these roads over here, they don't also have crossroads turned on. If I come over here, I still have that same option, can turn on. And there you go. And this could, this doesn't necessarily have to be a crossroad. It could be a barricade. It could be lots of different things. You could make additional options here. You could turn on a crossroad 1 or crossroad 2. All you would need to do is just come over here to your integer selection here and make another switch and switch to something else. First thing I do want to mention before we jump into this is that if you are not familiar with splines themselves, we can click on any of these points here and we can scale them. But we can, add additional width to our road at different places with one of these points here. But it's a little bit janky, as you can tell, and we probably want settings that can control the width of our road, not at each point, but as a whole, because probably you're using the same mesh and you want to have the whole width of the road change at once. And so that we need to go ahead and do in our PCG graph. So I'm going to zero this back out here. So let's go ahead and open our PCG graph. Here are nodes that we already built, and the place that I want to add width to my road is kind of early on in the graph. I have this surface sampler here, or the spline sampler rather, that's sampling this get spline data node. And right after it is where I want to add my width control, because I want to add a width control that controls my road meshes and my crossroad meshes. If you wanted it to just control your crossroad meshes, you would do it right after, or you do 2 of them. But I want to make one control that controls both of them because they're technically the same road. And so I want their width to be comparable to each other. So what we'll do here is we'll right click and create a multiply node. And we will hold down Control to kind of grab the end of these outputs here and click and drag them into this new one. And we'll click the A into out on the spline sampler here. So what we want to do with this node is multiply the scale of the y-axis of our points. So to do that, we'll take an input into B, and that input into B will be multiplied up here on the import source 1 by scale. So we'll choose scale here, but we don't want it to be the whole scale of the point. We just want it to be the width. In this case, that's the y-axis. So we'll go ahead and hit scale and then hit a period and then y. This is how we choose to multiply our number, whatever we put into this multiply node, by not just every scale in every direction, because it's technically 3 numbers, right? It's width, depth, and height, x, y, z. But we want to have it multiplied with on just the y. So this is a way that we can just pinpoint just the y and say, I want to multiply a number by that width. So now we need the number, the parameter. We could create a parameter in our graph, but because we're using a blueprint here as a tool, when we drag into our world, we have something available to us, which is to come over into our blueprint that we put our PCG graph into, and we're going to come over here to the variables section. And you'll remember we added a variable to turn on and off the crossroads at the end of our road. So in this case, we're going to go ahead and make a new variable, and this one we will call road segment width. And we'll go and check on the eyeball, and this one will switch to be a float. We'll go ahead and hit compile, and we want to make sure that this has a default value that makes sense, that won't automatically scale our road unless we go and decide to change it. So that will probably be here where we'll switch this to 1 here, and the default value with our road segment parameter or variable rather selected, we'll change it to 1, and that will be the default value. So now we hit compile, we can come over to our graph and we can use our get actor property to get that exact property. We can probably just copy the name here under the variable name. We'll come back here, choose our get actor property, and we'll come here to the property name, which is where we tell the get actor property node how to get the property because it gets it by name, and we'll put in that name we've copied, and now it will get that property. Now we can come to our multiply here and we can plug it into B. So we'll go ahead and hit save. Let's see if this worked. So now we can go and we can click on our roads blueprint, and we have a new attribute here called road segment width. And now we can go and increase that, and it will go and dynamically increase the width of our road uniformly. Awesome. So that works very well. Let's go ahead and zero it out. Next, what if we want to increase the segment width? So we have our width of our road this way. What if we have different mesh segments? It's a little hard to tell on this road because there's no texture, but depending on the mesh that you're using, they might be stretching a little bit or squished a little bit. So we need to go ahead and add a property for the road segment not in the y-axis, but in the x-axis. So let's come back to our graph here. So what I want to do here is come to my spline sampler. Now, if you remember, when we came to our spline sampler before, we were adjusting the distance increment, which is how many points would be sampled along the curve, and then those points were used to spawn meshes. So we can actually plug a property directly into this distance increment, and that will be how we can control how many, or like the width rather, of the meshes that we're using on the road, because more points will equal more meshes, which will squish them together a little bit, and that's just an easy way to control that. So let's go ahead and come over here to our road blueprint again. We'll make a new variable, and this one we'll call road segment length. And this one we want to hit compile and add a default value of 800. And the reason I'm doing this is because I checked over here and I saw that the attribute that we're going to be changing is distance increment in the spline sampler, and it is 800. So I'm going to come over here to the blueprint and add that in as a default value. Okay, we've done that. Now we will need to hit compile, come back here. I can copy and paste one of these get actor properties, and this time we'll go and add in our new name, which is road segment length. And if we don't get an error, that means I've typed it in correctly and it got the property. Now I can expand my spline sampler here, and the one we want is distance increment here. And we can always double check what the name is by clicking on it, distance increment. So I found it here, so I'll click and drag and put that into my get actor property that I'm getting from my blueprint. So we'll go ahead and hit save. And now we can come back here with this blueprint selected. We now have a segment width and length. So it's a little hard to tell with this mesh, like I said, but this is actually changing the number of meshes that are repeated along my spline, therefore changing their width in relationship to each other. So what if we have our crossroads turned on here? How do we change the length of this segment? Because we do have a control for the width of our road, which, because of the way we set it up, controls the width of our crossroad as well. But we don't necessarily have one for the length, because this length we set up to control the segments, all of the segments. So it's really going to be, how many times things are repeated, and therefore that will affect, how long this is repeated. So what if we need a control that's very specific to just this crossroads and not affected the rest of the road? Like maybe this particular mesh is a little different and we need it to connect to another road and its width is not quite lining up. We need something to be able to control that separately. You got the drill probably at this point. We want to come back to our blueprint. We're going to make a new variable here, and this one we will call crossroads, or crossroad, and we'll call it length. Turn the eyeball on, and this one I want to make a 1 by default, because that's a good place to start with variables that we're not sure what they need to be yet. So I'll start by making it 1. I'll hit save. I'll come back over here. So where will we put this? So this one here, remember here, we're getting our index for our end of our spline here, and then we're making a new index, getting the other point earlier on the curve, and then we're using that to subtract, and we're getting the difference between them by subtracting their positions, and then we're adding those positions back. So that means that when we go ahead and we add this position, if we add a multiply right before it, we can change how far that point is getting pushed, forwards, and therefore that will be used in creating the spline that we then spawn our mesh on. I think you get the idea. We'll go ahead and we'll drag these nodes over a little bit. All right, so we'll go ahead and right click and type in multiply, and we'll disconnect these and put it in between here. Then we'll create a new get actor property, and this one we want to grab our name, which I already forgot what it was, crossroad length. Hit compile and save, which then I can find my spelling error here and fix it. There you go. See, happens to the best of us. All right. So now I'm going to come get crossroad length here, and we're going to put that into get actor property, crossroad length. Got it. Okay, we'll plug that into multiply. What we want to multiply here is the position. So we had our position of our new point, And we got that differential by doing the subtraction. So by multiplying whatever this number is by the position, we're giving it an additional offset. We'll go ahead and in the input source, we'll choose position, and in the input source 2, we can leave as is. So let's go ahead and hit save, and we'll come back to our blueprint here and let's test this out. So now we have our crossroad length. Now if we increase this, there we go. Now it's adding an additional offset to that point's position that's letting us actually change the width specifically of just the crossroads. Great. So this is awesome. Final thing we want to do here is that this is really useful. Basically all of our kind of scale and translation stuff is set up, but what would be even more useful, as I mentioned at the beginning of the tutorial, was to have an option on our blueprint here to swap in different meshes, because we don't necessarily want to have to go into our PCG graph and swap out the meshes every time we have a new road. For example, maybe I'm just using this simplified road and I want to replace it later with a more complicated road, and we want this tool to be reusable. We want to be able to reuse it over and over again, drag it in easily, and so part of that is being able to choose a custom mesh that we can put in. So I'm going to come over, and first let's go ahead and make our parameters in the blueprint. That's a good place to start. So I'll come to my variables and we'll hit the plus button, and this one we will call road mesh, and we'll hit the plus button again, and this one will be called crossroad mesh. Okay, turn on the eyeball so that they're visible outside of the blueprint, and the float option here will switch to be a static mesh. We want to choose static mesh object reference here. And we want to do that for both of them. Static mesh object reference. This is the kind of variable that it is, which in this case is a mesh. So that's good. We'll go ahead and hit compile and save. Actually, before we do that, we want to add a default mesh in here just in case, so that when we drag it into our viewport, we don't, see nothing. So we'll go to our road mesh and we'll drag in the road mesh that we've been using and the crossroad mesh as well, because once we add this in, it's going to overwrite things we've set up in the existing static mesh spline spawner. Now we have our variables set up. We'll go ahead and hit compile and save. We'll come over to our PCG graph, and now we need to go ahead and add those attributes in. First thing we can do is go ahead and get them. So we'll get actor property rather, and the get actor property will rename to be road. Actually, this is crossroads down here, so we'll call this one crossroads mesh. In order for this to work, that we add a mesh on our blueprint and it's read down as a property and then spawned that way, we need to go ahead and add it to our stream of data here so that the static mesh spawner picks it up later and spawns whatever mesh needs to be spawned. So what we're going to do is use an add attribute, and this node is going to come in between here. You have to plug the in first because it will tell it what kind of data it is. I tried to plug the out in first and it didn't work. So make sure you plug the in first so it tells the add attribute what kind of data is coming in, so you can plug the end in. Okay, and we'll go ahead and connect our mesh here to the add attribute. We're going to click on the add attribute, and this one here, basically the output target, we need to give it a name to save the mesh under. This name doesn't really matter. For example, when we expand our data here, if we go ahead and hit A, it's just going to be one of these attributes here, and it's going to contain a mesh. So it doesn't really matter what we call it. I usually just like to call it mesh to be safe, to kind of remember it. But so I'll go ahead and click on the add attribute node, and under the output target, we'll call it mesh. So now if we scroll over here, we can see there's a new mesh attribute here. If we expand, it would show our mesh in there. Okay, so now that we have that attribute, we can pick that attribute up later with the static mesh spawner. Now, by default, you can see that we add the descriptor mesh in here, but in this case, we're going to forego this mesh descriptor and come down here to the spline override description. This is a little bit different than if you were to do it with the static mesh spawner, because we can just kind of choose that attribute. If you remember static mesh spawner here, we could come over here and under the mesh selector type, we'd switch to selector by attribute. The spline mesh spawner is a little bit different. Instead, we have to make an override. So we have to come over here to the spline mesh override description, hit the plus button, and this is going to be a way to override one of these kind of options here. And in our case, specifically the one that's not listed here, because the mesh is not listed as an input. So we'll come and we'll choose our input source, which is going to be the attribute that we saved our mesh into, which you'll remember is mesh on this attribute. So the attribute source is, where'd it go? Here, mesh. And what property is it going to overwrite If we click on this spline mesh here and we expand our mesh descriptor, this is the one we want to overwrite. And you can try to type in the exact name here, static mesh, or we could right click on it and copy the internal name. And what this is going to do is make sure that we're getting the exact name of this attribute with any spaces or whatever specific way that it's written and is understood by the node itself. So it's kind of a shortcut to needing to like try things. So once we've copied that, we can come down here to the property target and paste it in. And you can see that it picks up our mesh exactly as we want. Minimize here, and we can see our new road mesh attributes have popped up here. So if we wanted to go ahead and add a different mesh here, if we, I don't know, something random like this to our crossroads mesh, plug it in, and now it's adding that mesh instead. So we can just drag it in and it will replace our meshes with whatever we want. So let's go ahead and do that for our other road mesh. So we'll come back and we can actually just literally copy and paste this whole thing here, copy and paste, and we'll come back over to our road section and we'll delete that and we'll paste it right in. And this one, instead of the crossroad mesh, we'll change it to road mesh. We'll hit save, and now the road mesh works as well. And this is also, you know, like this doesn't have to be a road now. You can tell we can add all kinds of things in here. These could be a lot of different types of meshes. It doesn't necessarily, it could be a fence, you know, a line of fences. It could be lots of different stuff. But now we have all the tools available to us here in this spline blueprint to create any types of rows that we need. All right, there we have it. Thanks so much for joining me for this tutorial. If you got a lot out of it, hit the thumbs up or let me know in a comment. If you're interested in learning Unreal Engine from me directly and having me make custom tutorials for you, being part of a private group and getting access to all my courses and coaching, you might be interested in Aziel Art Academy. You can find a link to that below this video. With that, I will see you in the next one.